Hello and welcome to today's lesson on working with the special triangle, the 30, 60, 90 triangle. This triangle is used enough in mathematics that we want to understand that there are some shortcuts to be able to work with these values and find the values quickly. But then we also want to understand that we can use equal proportions to always solve any of these triangle problems as long as we have our reference triangle. Okay, so now when we look at the 30, 60, 90 conjecture, if we've got a conjecture on it, we know that this is something that's being used a lot overall. So the basic rule, the basic rule is that if the shorter leg length is x, we're just giving it a generic value, what we'll do is we'll build a reference triangle and put some values in there. Then the longer leg has a length of x times the square root of 3, and the hypotenuse has a length of 2 times x, or x times 2. Okay, so this is our generic situation for the 30, 60, 90 triangle. And the one thing I'm always going to talk about is building the reference triangle. Okay, the reference triangle, the most basic 30, 60, 90 that you can build, has a short leg of 1. That means that the long leg is square root of 3, and the hypotenuse is 2. So once again, if you're given that short leg value, these situations can really give you some quick answers to find the other two missing pieces. Okay, but now once you're given one of the other values, okay, to have to work through and find the other pieces that are missing, that's where equal proportions is a great skill, because it's an enduring skill of geometry and almost all of mathematics. Okay, so now this is our basic 30, 60, 90 problem. We're given the short leg of 5, so we can use the conjecture, and we know that the hypotenuse is 2 times the short leg, or 10 centimeters, and the long leg is square root of 3 times the short leg. So we have 5 square root of 3 centimeters. Okay, now, once again, this is a memorization skill, so if you're not quite there every time, the one thing that you want to do, because it works for any 30, 60, 90 triangle, is build your reference triangle. You could have this in your notes when you're doing your homework. Okay, you will want to memorize these reference triangles when you're taking the test and drop those in. But now, if I'm wanting to find these other pieces, I'm going to call this x and I'm going to call this y. What we want to do is set up equal proportions. So from my triangle, x over 5 is the ratio of the hypotenuse to the short leg. Now if I go to the reference triangle, I can build the same ratio based on the hypotenuse and short leg values. Okay, once I do that, whenever we're dealing with equal proportions, we've got one fraction on each side. All we have to do is cross multiply and solve. And you can see we get that answer that we got using the conjecture. But this is an enduring process, a process that you always want to keep in the back of your mind. Can I set up two equal proportions? If I can always cross multiply and solve to get the answer. Okay, just to show with y. Okay, so long leg y over short leg 5 equals, and now I'm going to go back to my reference triangle and set up the same ratio, the same fraction. Square root of 3 over 1. And then from there we cross multiply and solve, and we can see that we get the values that we're looking for. Okay, so once again, if you're given the short leg, the conjecture is a great way to go. The hard part is if you're given any other value, you have to be very careful with your mathematics. And the one thing that you can do to make your math work every time is just set up those equal proportions based on the reference triangle, and that will really help you in the long run. Okay, now looking at some examples here. This is a prime example, so we're trying to find some of the other pieces. Okay, so we're trying to find the short leg x, the hypotenuse y. So this is where I would strongly suggest making sure that you have your reference triangle, and try to build your reference triangle so it looks the same way. And you're always talking about short leg, long leg, and hypotenuse. So if I'm wanting to find my short leg here, short leg of x over long leg of 7 equals short leg of 1 over long leg square root of 3. So here is my triangle on the left, and this is the same ratios from the reference triangle on the right. And then from there we cross multiply and solve. X times the square root of 3 equals 7 times 1, or 7. Now we need x by itself. Divide by square root of 3, divide by square root of 3. And now I've got x equals 7 over the square root of 3. Now, like we talked about in one of our last lessons, we don't want a radical in our denominator, so we want to rationalize the denominator by multiplying that value top and bottom. So we're not changing the number, all we're doing is changing some positions of values and how the value looks overall. So square root of 3 times square root of 3 is square root of 9. Square root of 9 is 3. So what I've done is I've turned my denominator into a rational value instead of an irrational radical value. And then we've got 7 square root of 3 on top. Another situation where we're given the long leg value. Okay, now, if we were wanting to find the hypotenuse, okay, we would have to work through a very similar relationship. Okay, so what I'll do here for this one is I'll actually try to solve for the hypotenuse value. Okay, once again, using my reference triangle. So hypotenuse over long leg equals, and then now I need my values from my reference triangle. Hypotenuse is 2, and the long leg is square root of 3. Okay, so once again, we're making sure that our proportions are equal to each other, and then we can cross multiply and solve. X times the square root of 3 equals 2 times 9, 18 square root of 3. And then from here, we would want to divide both sides by the square root of 3, and we can see that there's 1 in each, so they can divide out, and we get a hypotenuse value of x. Okay, next example here. Okay, we're given the hypotenuse length. Okay, and for this one, I'm going to end up finding the short leg length, x. Okay, so if I'm given hypotenuse and I'm trying to find short leg, that is my first ratio. And then I just want to look back at my reference triangle. Okay, and I've got 2 for the hypotenuse, 1 for the short leg. Okay, so I'm setting up that equal proportion so I can cross multiply and solve. Almost made a quick mistake here. Okay, you always want to be careful about setup. What I did is I made a setup error of my proportion. Okay, it should have been 1 on the bottom, short leg, and then 2 in the denominator for hypotenuse, hypotenuse. Okay, so we have 2 times x equals 12. Divide both sides by 2, and we get x equals 6. And then we can use our ratios to find, or use the conjecture to find our long leg, 6 square root of 3. Okay, because once you have that short leg, finding the other 2 is a little bit easier. Okay, so now, once again, finding missing sides. The one thing you want to just be careful of is how the triangles can be orientated differently. So I'm not going to go through all 4 of these based on time, but I'm going to go through a couple where the orientation is different, and we just want to be careful when we set up our ratios and solve from there. Okay, so now we've got our 1, 2, square root of 3, short leg, long leg, hypotenuse. Okay, now this is our best case scenario. We're given the short leg. So if you're given the short leg, hopefully you can use the conjecture. Short leg times 2 is your hypotenuse. And short leg times the square root of 3 is your long leg. Okay, so you want to be careful, though, the way that it's orientated, to be able to look for and solve those values. Now, for these bottom 2, okay, using equal proportions to find x and y, okay, you always want to try to find the short leg first, because that's going to make it easier to find the long leg. We can multiply by the square root of 3. So now I've got a hypotenuse of 20 over a short leg of x equals my hypotenuse of 2 over 1 for the short leg. Okay, so once again, given triangle, reference triangle, and then we cross multiply and solve. Divide both sides by 2, and we get x equals 10. Now, once we have x equals 10, you can always set up another proportion to solve for y, or you can use the conjecture and know that it's always just the short leg times the square root of 3 to get your long leg. Okay, now, last one here. This is one that's going to be one of the more difficult ones. We saw it on one of our examples before. Okay, to get our short leg x, okay, long leg over short leg equals long leg over short leg. Okay, so this is going to be one of those problems where we have to rationalize our denominator. Okay, we cross multiply to solve. X square root of 3 equals 9. Divide both sides by the square root of 3. So we've got 9 over the square root of 3. And remember, we don't want radicals in the denominator. Okay, we want to rationalize, turn it into a rational number. So we multiply both numerator, denominator by the square root of 3. So in the denominator, we get the square root of 9, or 3. And then we've got 9 square root of 3. And then we can also do some simplifying here. Okay, 9 divided by 3 is 3. So we've got 3 square root of 3 for our short leg. And now we can use the conjecture to get our long leg of y. You can always use the equal proportions and cross multiply and solve. Okay, but we also want to understand that short leg times 2 equals your hypotenuse. Okay, now, last thing. The most common type of problem we have is using an equilateral triangle of some shape and trying to find side lengths. Now, the reason why we can find all different measurements from the equilateral triangle is the fact that if we cut it in half, what we've actually done is built 2 30, 60, 90 triangles. Okay, so we've got 16 for our hypotenuse, and when we cut this side length in half, we cut it into an 8 and an 8 for the 2 bottom legs of the separate triangles. And now this allows us, with cutting it into a 30, 60, 90, to find the height of this triangle, which is x. Okay, now, if you can use the conjecture, that's great. If not, remember that we can always set up proportional ratios. So x over 8, okay, long leg over short leg, equals our reference triangle, long leg over short leg. And then we can cross multiply and solve to finish that up. Okay, so always remember, if you have an equilateral triangle, the thing that we want to remember is that we can break it up into two 30, 60, 90 triangles. Okay, and then we can use our conjectures of the 30, 60, 90, or we can use our reference triangle and equal proportions to solve. Thank you, and have a good day.